Hello everyone, my name is Mohammad Adnan Shafiq and welcome to my Google Data Analytics Capstone project on Chicago Cyclistic dataset. In this video, I will cover and walk you through the entire journey of converting raw data into valuable insight. By using R language on Kaggle platform, we will cover the following: data cleaning and data preparation, exploratory data analysis, data visualization, and finally, my recommended strategies for capturing the market share. This is a complete video for fellow learners or data enthusiasts on showing you guys how I solve and tackle the problems in this project step by step. As an added bonus, I have also included a PDF presentation on step by step guide for this Google Capstone project. Link will be in the description below. Not only that, my Kaggle account link will be also be in the description below, so you can check that out as well. If you like this video, please like, subscribe, and comment. And I would love to hear your thoughts on this whole project and any suggestion for improvement. Now let's get started. This is my Google Capstone project on Kaggle in R language. I have already preloaded this to save time. As you can see, all of the details are clearly mentioned, what steps I have taken to complete this project. All of the code and its output is already in this notebook editor. The link will be in the description of my Kaggle account as well as the PDF file for presentation, which I'm going to share with you guys shortly. Okay. So you can easily replicate it for your own portfolio projects or to learn how to analyze data sets in our language. So these are very easy to understand. I have added all of the details for your understanding purposes. Here is a complete overview. And this is the complete outcome of my project. And before we take a deep dive into step-by-step process on how to complete this project, I'm going to share with you guys a small video on how to use the Kaggle platform, because there are some new users who don't know how to use it, or new learners. So we are going to check that out, and then afterwards we are going to move towards how to complete this project. Thank you. So for example, I'm going to select the Uber Data Analytics dataset. I'm going to click on it. I have already clicked and loaded the page. This is the page which is going to appear. I'm going to check the details regarding the dataset. If I like the dataset, okay, and if I want to continue with the project, I have to do nothing. Just go on the top right corner, click on these three buttons, three dots, plus new notebook. This is going to load me into the Uber notebook editor, right? Dataset notebook editor. First thing I will have to do is going to change the name of the project. I'm going to write Uber dataset project. Okay. I'm going to check the dataset. Yes, the dataset is available here in CSV format. Now I'm going to select the language, Python and R language, right? So I'm going to select Python by default. To write the code, I have to do nothing. Just click on plus code icon and then write the code. For example, import numpy as np. And if I want to add the comment, hashtag, whatever the comment is, and then click on execute. The code will run. It is going to connect my local machine with the Kaggle cloud-based services. It is right now connecting with the Jupyter kernel in cloud and fetching the library for Python, as you can see. Furthermore, if I want to add the details of the code or what I have done, I can click here on plus markdown. Here I can write any comments or details pertaining to the code This option will help you to showcase, make a project and showcase to your employer what the particular code is about and why it is written and what is the outcome of that particular code. It is very simple. Now, once I have completed the project, I will have to do nothing. I will go to the top right corner, click on Save Version, change the name, and click here in the Save section. And it will save the project here, as you can see. Now, if I want to check if this data set is saved, okay, I have to do nothing. When I am on my landing page or my account page, I will click here and go to your work section. As you can see, the data notebook editor, the current project is loaded here. So the project is smoothly saved, and I can, whenever I want, I can continue the project by selecting this file. It will directly load me to the project, and I will click here on edit section, and from edit section I can edit the code. So guys, this is the landing page. Now we are going to start our Google Data Analytics Capstone project. Before I start the project, I want you guys to know that we are going to be selecting Cyclistic Bikeshare dataset for completing this Google Capstone project. And the goal of the analysis is to uncover usage pattern, compare customer behavior, and provide data-driven recommendation to convert casual riders into annual members and to capture markets. Now, you might ask why I choose this case study. The reason I choose this case study is this project offers a practical application of data analytics in a business context and allow hands-on experience with data cleaning and pre-processing, EDA, exploratory data analysis, that means identifying trends and usage pattern, data visualization and insight, creating charts and dashboard for communicating findings, and finally the business strategy for development, making data-driven recommendation or suggestion to increase the membership. Additionally, in this case study aligns with the real world business decision making, making it an excellent opportunity to apply analytical skills in a structured way. Now, the key objective is to understand the customer usage pattern, casual versus annual member, identify trend in ride duration, peak usage time, station preference, and the approach and methodology I will be using, since this case study is a part of Google Data Analytics Professional Certification for Capstone project, I will follow the following data analysis process as outlined by Google. Number 1 is ask, number 2 is prepare, number 3 is process, number 4 is analyze, number 5 is share, and number 6 is act. These steps will form the basis of my data analysis and analytics on the Cyclistic dataset. So let's start the project. So first thing we need to do is go to the dataset options in the right columns. Here, as you can see, there is a search bar. I'm going to write Cyclistic Bikeshare, press enter. This is the dataset I want to use for this project. Cyclistic Bikeshare by Yvonne Grover, updated 3 years ago. So this is a very popular dataset for Google Capstone project. I have already checked the detail, but you can check all of the details for this dataset. And one more thing to note, that the dataset is around 1.06 GB and it have 12 CSV files. Okay. So now I will go to the top right corner, click on these 3 dots, then click on plus icon. The notebook editor will load. Then I will have to change the name of the project on the top left corner, which is Cyclistic Bikeshare Dataset Project 1. You can name it however you like. Press enter. Now this is the project name. And as you can see in the right corner, first we are going to check that all of the 12 CSVs are here. Yes, they are. Then we are going to go into the session option and check if the language is selected R. And yes, it is by default selected as R language. Now, I'm not going to write all of the details on what each thing does, but I'm going to write the code and explain it to you. So it is very simple, but if you want to follow it, you can check my PDF presentation, which will be in the link description. So it will be very easy for you to replicate this project for learning purposes or making portfolio. So now I'm going to click on plus board icon. Now here I'm going to first load packages, and I'm going to write hashtag load packages so I can know what this code is used for. Here I'm going to type library, going to give the columns and write, sorry, brackets, and then write tidyverse. And I'm going to load one more library, which is Geosphere. Okay. There is a mistake in my typing. So this is the packages which I want to load, because without these packages, you can't complete this project. And why is that? Tidyverse library is used for data wrangling, cleaning, and visualization. So it's going to load all of those packages which are used for data wrangling, cleaning, and visualization. On the other hand, Geosphere is used for calculating distance between start and end session. It is used for calculating longitude and latitude, calculating distance between the start and end station, and geospatial analysis of mapping. So it is a very good library in our language. Keep that in mind. So we are going to hit the run code or the execute code. And now the R language, as you can see, is fetching the data. It is going to take a little bit of time, so be patient. But it is going to load the data set. Here, as you can see, the data set is loaded and all of the packages have been loaded. And there, you can see one more thing, that there is a conflict error in the tidyverse. As you can see, Geosphere has already, tidyverse has already loaded all of the packages. Geosphere have some of the same packages. So due to duplication, it has stopped the Geosphere packages, but that's not a problem. We can continue. It will load all of the packages. Now, the second step is to import the data set. So what we are going to do is I have already copied this. It is a long code. We are going to go on the top right corner, and as you can see, there are numbers written here. 1 till 11, 12, right? So you need to do is write it, then copy it, then change the name from dataset 1 to dataset 2, and also change this to 2. Now we are going to repeat this process till dataset 12. So I know it's a little bit lengthy, but in data analysis, we have to work long hours and do these type of things to get the end results. So I'm going to repeat the same process, and you can see that all of the data sets have to be loaded. Without that, we can't complete our analysis. This is data set 5. I have written here 5. Now we are going to load the data set 6, and this is the 6th one, and now the 7th data set is being loaded here. And note that I am changing the serial number of each CS. All of the other details must remain same. No need to change anything. Otherwise, the data set won't be successfully loaded in this. Now I'm going to write the data set for ninth one and the 10th one. There is a double quote, so 10th one, yeah, it is 110. So be very careful. You need to change it to 110. As you can see, there is a little bit difference. 209, then 110. Okay, now we are going to load the 11th one, and I'm going to load it to triple 11. Yeah, to triple 11. And the final one, hopefully there is no mistake in this load. Otherwise, the data sets won't load as we want it to. Now, all of the data sets have been loaded here. And now we are going to click on the execute. And as you guys can see that the data set is being loaded and heavy usage in RAM. Let it load. All of the 12s are being loaded. And as you can see that all the 12 data set has been loaded. And one more thing to note that you need to check this. Each data set has rows and columns. This, for example, the first one has 1 lakh or 103,770 rows and 13 columns. So all of these rows and columns have been loaded, and each data set contains 13 rows. So that is a union between all of the data sets. That's good to know. Now we need to check it further. So we are going to use a old school technique or trick, you might say, of glimpse function. So what glimpse function is going to do, I'm going to tell you in a gist. Give me a minute. I'm going to write the glimpse. And for example, we are going to select dataset 12. And we are going to execute the code. So what glimpse function does is to let you know the column IDs, the column details, what are the titles of the columns and what dataset it contains. So as you can see that the 13 columns we have, all of the titles are here and total number of rows and each and everything. And we can counter check 247,540 rows, and here in the 12th data set you can see the same number. So before EDA process, you can use glimpse function to understand how how many columns you have, how many rows you have, what type of data you are working with. So it's a very useful technique, and I think every data analytics person who is using R language for their analysis should use it. Now let's move further. So guys, now we are going to check we have already checked in the rows and columns. Now we are going to start the data cleaning process, and it is not very difficult. Once you get the hold of it, it takes time with practice. I am also a learner like you guys. So first thing we have to do is to merge the data set. And for merging the data set, first let me write the comment so we can know what this code is for. Data set. For merging the data set, we are going to use the trip function in our language. So it is very simple function, but very useful one. We are going to write trips. Then we are going to write find underscore rows. This is the main command. Now, which rows? We are going to select each data set. You remember we have here given name while importing the dataset 1, 2, 3. So our language has already characterized these data sets into these CSV into these dataset names. So we are going to write the same name here, dataset 1. Now we are going to write dataset 2, data 3, data 4, data 5, data 6, data 7, data 8, data 9, data 10, data 11, and last but not least, data 12. So this command is going to merge it. And now I'm going to execute the code. Oh, I think I have made a stupid mistake here. I forgot to add rows because there is more than one rows. So that is why it is giving the error. Now we are going to execute it again. Now it is working. So if it is not giving any error, that means all of the dataset have been merged up. So now we are going to check the missing values. We are going to now go to the add code icon again. And first I'm going to let you know what is the code I'm going to use for will do. So first of all, checking the missing values. Number 2, this counts missing values as NA for each column in the trips dataset. Number 3, the output. Sorry, spelling mistake. Output helps determine which column have NAs not available and how many. Okay, so what is that command? It is very simple. We are going to use all sums and we are going to write is NA is an operator. Okay, is an operator, and where we want to use it, we want to use it in the trips function. So this is one, and we are going to now write the second code. I'm going to write 2 codes here. Okay, so second code is we need to remove rows with the missing values. Also, we want to delete any rows containing the NA values. That means we are specifically targeting not available values. Okay, in any column. Also, we are going to add, this will also ensure the data set, sorry, spelling mistake. Data set is clean, but might reduce data size significantly. Hashtag. If many rows have missing values. So what is the code for that? We are going to use trips again, and we are going to use the greater than and less than operator and write trips again. Then we are going to give quotation and then quotation close, drop, percentage underscore NA and bracket close. Okay. Now we are going to run this code. Both of these commands will help us to remove any missing values. And as you can also see, the complete values column with missing details are highlighted here. And for further detail, you can check my notebook editor with the complete code. Okay. So the next step I'm going to take is break down the data for data cleaning and transformation process. Okay. So I'm going to write it. The code for creating a month column, and for creating a month column, first let me write the comment so you guys might know what I'm doing. So this is the comment, and now I'm going to create the months column. So I'm going to use the trips function, and note this, that trips function is very important, guys. So you need to use it quite often when you're cleaning, processing, or transforming the data set. Trips $months. Now I'm going to use the greater than operator and dash format. Now I'm going to write as operator date. Then I'm going to add another bracket and then rewrite the trips dollar started underscore add bracket close comma, and I'm going to add percentage E. So this code will be used for creating month. Now with creating month, we also need to create the year column and the week column. So I'm going to create the year column first. You can create however you like. So creating year column. Same process, use strips, then dollar, then write year, then use an operator, then use format as date, then again semi bracket, and use strips dollar started underscore add, and now we are going to use percentage by to represent year. Okay, so this is completed. Now we are going to create a week column, creating week column, days of week column, week column. I'm going to use the trips dollar and give the title days underscore of underscore week and use an operator again. Then I'm going to write format, same process. Once you get the hold of it, you will understand it is very easy to create columns, dates, trip, then write trips, dollar again, started underscore at. Now I'm going to denote the sign percentage E. Once this is done, we are going to move towards hashtag creating our column. And for this, we are going to change the code a little bit. And we have to do nothing. We just write trips again. Okay. Use the operator again. Then use again trips. And give the percentage sign greater than percentage close. Then we are going to do write mutate our, which is equal to ST RF time, and then we are going to give the semicolons and write trips dollar ended underscore add comma, and in this we are going to give the semicolons percentage for denotation H. Okay, so this is the code for creating the hour column. Now we are going to write hashtag creating ride length column in minutes. Please note that this is a very crucial stage because without this, you can't data visualize the data. So that is why we have to create these columns in order to extract the data we want to. Okay. So I'm going to write trips dollar ride underscore length and use the operator again. Now I'm going to change the code as double add diff time, then use another operator because I'm using two formulas in this trip function. Okay, so trips then dollar sign ended underscore add comma trips dollar sign started underscore add, and we are going to divide it by 60. Okay, so this is how you are going to get your data into minutes. Okay, we are converting the data and also creating the column with these three formulas into one. So it's a little bit lengthy, but not difficult. And for understanding what each of these does, you can check again. I will quote that you can check my PDF presentation file, which have the complete details. Also, you can check my notebook editor of Kaggle, which have all of the details written for your understanding. Now we are going to create ride distance column in kilometers. So we are going to write the comment creating ride distance column. We need to calculate the ride distance. It is very crucial. Otherwise, we won't understand what annual and casual rider length of distance travel is or time spent on kilometers. So this is very critical that we create one one of this column. So we are going to use that distance formula for this one. We are going to write trips again, ride underscore distance. Now operator distant geo. Okay, metrics C column again, trips dollar sign. We are going to use a dollar sign. Now we are going to calculate it using start underscore LNG for longitude, and we also want to calculate it in latitude. So we are going to write trip dollar sign start underscore lat. Okay. Now we need to do one more small tweaking here. We are going to use npol equals to 2. Okay, so comma. Now we are going to add this line again. So I'm going to just copy this one from here. Sorry, I'm going to copy it from here and bold 2. This one we need to type it again. Okay. So 2 times, right? We need to write it 2 times and close it off double brackets. So this is the code for that. And we are also going to add one more thing before completing this. Trips dollar ride underscore distance. Use the operator trips dollar sign ride underscore distance divided by 1000. Last and but not the least, I'm going to also add ordering is of week column. And we are going to write trips again, dollar base underscore of underscore week. Use the operator ordered trips dollar base underscore of underscore. This is the heading, so we are going to write it. Then we are going to comma, add comma, and we want it. The reason I'm adding this is because we want to get the days in text form, like Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So I have to add this, and I'm going to add levels equals to C bracket open. Now I have to let it know what I want. So the compiler can understand what I want and how to execute it. Tuesday. Here I'm going to write the Wednesday one. Wednesday. Sorry, spelling mistake. Comma. Now I'm going to write the Thursday one. Thursday. Comma. Friday. And I want the weekend ones as well. So I'm going to add Saturday. lastly, Saturday and I'm going to give Sunday. And because we need a double bracket to process. So these are the details we want. Now we are going to. So guys, after this, I'm going to copy it again to save time, and we are going to do it by month. Okay, so we are going to change the comment to month, and we are going to do the same process, except we are going to make a little bit amendments here. It's going to be month, it is levels, and here we are going to write the name of month, January, Feb, and yeah. Here, and it will be March, then April, then May, then we are going to do it after May. We are going to write June. So these are 6 months. And now we are going to type July, J capital, and August. And now we're going to write September, October, November, and November, and finally December. So this is the code for that. Furthermore, I'm going to be renaming two columns which did not have the column ID title, right? So what was those two columns which we found on glimpse function? Well, the two columns names are names, scripts. So here we are going to write. Second column did not have the name and the data was pertaining to the bike. So I'm going to write it, give it a name of bike and copy this one code again. And the second column was column 13, which pertained to user data. So give it a name of user. Further, I'm going to remove any columns with any rows with NAs. And I'm going to use strips drop underscore NA and then trips. And then we are going to remove rows where writes were negative and write trips space lesser than minus trips big bracket exclamation mark trips dollar writes ride underscore length lesser than 1 comma and one more thing, last thing we have to do is to remove rows where writes were above 1 day. So how we will do that is simply trips and use lesser than function minus trips and big bracket, and then use exclamation mark again, trips dollar right underscore length, which is greater than 40 minutes, comma. So now we are going to run the code. And the code has been successfully executed, no error given. Okay. Now what we need to do is to move to the next step, which is EDA, Exploratory Data Analysis, in which we are going to extract the key insights. So the next code will be for extracting key insights. So I want to extract the percentage. So this is the way to extract the percentage. I'm going to write user count, and we are going to go select lesser than trips, and we are going to select percentage greater than percent. Now we are going to use group underscore by user, and we are going to use percentage greater than percent. We are going to use summarize total, which it is going to summarize the total number of users, and we are going to use n empty brackets, bracket close, and again the same process, percentage greater than percent. And now we are going to write the mutate command, overall underscore total is equals to sum, and we are going to use total number of users, those, and percentage greater than percent. Now I'm going to use group by user percentage greater than, and again I'm going to use summarize percent underscore total equals to total overall underscore total. So total divided by overall total. And lastly, we are going to close this by writing the count. We are going to execute the command, and as you can see that this is the percentage of casual riders and member riders. Now as we move further, so guys, now we are going to check the bike distribution of bike types according to each user. So for that we are going to write a code, and the code is bike underscore usage trip percent. Those, there is one little bit more gap. Now we are going to group it by group underscore by bike, as we want to check the bike types. So we are going to group it by bike, percent greater than percent close, summarize total is equals to n bracket close bracket open. Then we are going to write again percent greater than percent close. Now we are going to mutate it. Mutate overall underscore total is equals to sum total, and again percentage greater than percent close. Now we are going to group it by bike, percent greater than percent. As you can see, I have made two types of groups, and now I will summarize it. Percent underscore total is equals to total divided by overall underscore total bracket close by underscore usage. Now we are going to run it. So there is one error I made. I forgot to add the trips function. Now we are going to run it. Now you can see that there is a table and it is showing each bike tags with its percentage. Classic bike around 70%, dog bikes around 6%, and electric bikes around 23%. So that's how you are going to check the distribution. Now we are going to further move towards another check, specifically on the annual members bike riders, and the code for that we are going to use is simple annual underscore member underscore bike type underscore used, and then we are going to again use the trips function percent close filter user equals to 2 times member, and then again we have to use percent greater than percent. Now we are going to write group underscore by. What we are going to group by? We want to group by bike, because we want to check the different bike types usage for annual members, right? The distribution for annual member. And again, I'm going to use the percentage greater than percent. Further, I'm going to again summarize it, and the total will be equal to n, and then we are going to use percent, and then further mutate it overall underscore total. What we want sum of total bracket close percentage greater than percent, then again group by underscore by bike and percent close, and now we are going to use summarize. What do we want to summarize? Percent underscore casual, which is equals to total divided by overall underscore total. And now we are going to write annual underscore member underscore bike type underscore. So we are going to run this code again. And as you can see, now we have the bike percentage according to the percentage of casual members, casual annual members. And annual member tends to use classic bike 76% of the time and electric bikes 23% of the time. Now we are going to further check the distribution of the rider average time duration, and for that we are going to use rider underscore time underscore user, then again lesser than minus trips function, then we are going to use percentage greater than percent, and we want to group underscore by user bracket close. Further, we are going to percentage greater than percent, close it, then summarize it. Now we are going to use the average time formula, which is equals to mean, and we want to check the ride length. So ride underscore LENGTH bracket close. Now we want to check the groups, which is equals to drop bracket close. Okay, so this is the code, and further we want to check ride underscore time underscore user, and with dollar sign average underscore time round riders underscore time underscore user dollar average underscore time comma digits. What are the digits we are going to use? We are going to use 0, and then we are going to write riders underscore time underscore users. So now we are going to execute this one. So it is saying that object error rider underscore time underscore user not found. So there is a small error. As you can see, I have added S here. Now we are going to try it again. User not found. Why it is not found? Because there is an error here also. And now we are going to run it. As you can see, now we have the average time of casual members riding their bikes on average and annual members. So casual members ride 28 minutes and annual members ride 13 minutes. So this is the main crux of the EDA process, as you can see. Further, now we are going to check on average ride duration by user types. So for that, I'm going to write another code. The code is riders underscore time underscore bike type bike types, and now use trips, then percentage greater than percentage, and we will group it by underscore by bike and user. Okay, two types of columns will be used. And now we are going to summarize what we are going to summarize: average underscore time, which is equals to mean. And now the reason we are using mean is to calculate the right underscore length. Okay. And now we are going to do the same procedure. We are going to write groups, which is equals to drop. And now we are going to write writer. Again, the same format has to be copied. Time underscore by types and dollar sign. What is the average underscore time we are going to use? And lesser than round function, bracket close, writers underscore time underscore bike types, dollar average underscore time, comma, and we are going to use the digit function here. I think the digits is equals to 0, and we are going to close the bracket. And now, last but not least, we are going to write writers time underscore by types. Okay, and now we are going to run the code or execute the code. And here it is. Now you can see that I have taken out or fetch both of the users average time spent on different bike types, or it is a distribution summary for average time spent on different bike types for casual and annual member. 26 minutes for classic bike, casual. Annual member on classic bike is 14 minutes, dog bike casual 50, electric bike 20, and electric bike for the annual member 12 minutes. Now we will further move towards taking out the average distance. So guys, here we are going to check the average ride distance by user type. So what is the average ride distance travel for casual and annual members approximately? So we are going to write the code of riders underscore dist for distance underscore user, and then we are going to give lesser than minus trips, and again the same thing, percentage greater than percent. Then we are going to group underscore by same. We want to group it by user, so we are going to group it by user, and then we are going to give percent and greater than percent close. Now we are going to summarize it. Average underscore, because we want to calculate the distance, and we are going to use the mean, and write underscore distance, bracket close, comma, and we are going to give group is equals to drop close, and we are going to give riders distinct underscore user dollar. As you can see, the same pattern is repeating, only the formula is changing. So now rider underscore distance user dollar average distance and greater than less than minus round. What is the round figure? Riders underscore test underscore user dollar average underscore then distance. Okay, and the digits, I want the result in 2 digits, so I'm going to use 2 and close. Now we are going to write riders underscore distance underscore user. And now we are going to run the code. And as you can see, casual member on average travel 2.2 kilometers approximately, and annual members 2.1 kilometer on average. So guys, now we are going to calculate the distance travel on different bike types by both user. So the code is simple. I'm going to write the code. Riders underscore distant underscore bike types for heading and greater than. We are going to use the trips percent greater percent, and it is grouped by bike, comma, user, percent, percent, summarize, average underscore distance, and there is one missing here. It is group underscore by. Okay. So average distance, which is equal to mean, and now we want to calculate what? We will want to calculate the right underscore distance and comma, and it is group, which is going to be used as rocks. And we are going to write riders underscore this underscore bike type. And what do we want to calculate? Average underscore distance, which is lesser than minus round, and riders underscore this. Again, we are going to write the same command types dollar average underscore dist, and for how many digits we want the output. So we want the output in 2 digits. Like that. And now we are going to run the code. I think there is a small error. Rider distance bike types. And the error is here is spelling error. And as you can see, now we have the data on average distance travel on different bike types by both user. Casual member 2.5 15 kilometers, classic bike, and annual member classic bike is 2.01. Dog bike casual is 2.04, electric bike casual is 2.44, and electric bike member is 2.39. Guys, now we are going to calculate the average ride distance by user for counter checking. So we are going to use AVG ride distance. Okay. And use strips again, then percentage close and group underscore by user. And now I'm going to use summarize, and I'm going to use every ride distance, which is equals to mean ride underscore distance. And as you can see, we are going to write avg name dollar. What we want average distance greater than minus, and rounded figure again average distance dollar average distance round figure, but digits will be 3. Okay. And average right distance, and now we will to run the code. It is showing an error. So there is a mistake. I haven't added the percentage symbol here. That is why it is showing error. And as you can see that casual member average distance travel is 2.2 kilometers, and annual members 2.09. And further now we are going to check the average ride distance by user types. So this is a lengthy one, and on this key insight I'm going to check the ride by user, rides by user in hour, not distance, sorry, distance we have already calculated, but we are going to check in hours. So it is, the code is hours, hour, and lesser than minus, then same function trips percent greater than percent close, and each time we need to do the group by function user hour and percent summarize. And what do we want to summarize with? Number of rides as our heading, and is equals to n. And now we are going to give it comma groups, which is equals to same prop function, and it is a single comma. And I'm going to use percent. Now we want to arrange the hour, and now we are going to close it, and let's see what happens. As you can see, the whole table, all of the details between casual and annual member and their trips by hour has been displayed. Now we are going to check hourly ride distribution has been checked. Okay. Now we are going to check the distribution of weeks. So for that, I'm going to write another code. So this code will be ride count by user weekdays. Okay. And to count the rides by weekdays, we will write, actually I'm going to give it a little bit space, days of weeks lesser than, and again the same function will be used, And now we are going to group underscore by user, and we want to group it by days underscore of underscore week. Okay, so we are going to calculate it in this method. Summarize number of rides is equals to n, close open, and groups, which is equals to drop, and days of week. Let's see what happens. As you can see, we have total number of rides by days of week, Monday to Sunday, for both rider types. Okay, so now we are going to calculate, where after calculating the weekly ride distribution, we are going to calculate by month. So the code for that will be ride count by user month. So guys, we are going to complete the last EDA part, and scripts percent group underscore by I want user and month, and we are going to complete it. Now we have to summarize the problem. So we want number of rides is equals to n bracket close and comma groups equals to drop. It is very simple formula but very useful one. Calculate the months, rides on different months. Let's see. And as you can see here, all of the months from January to December for both member total rides have been displayed from the data set. Now we are going to move towards the data visualization part, and the codes are a little bit lengthy. So guys, we are going to write the code now of the pie chart, and as I already told you guys that it is quite lengthy, so first I'm going to write the code and then I'm going to explain the code, what the function of the whole code is, how it operates from backend. And once you get the gist of it, then for the next data visualization codes, it will be very easy, so I don't need to explain it to you guys. So that is the process, and let's start the code. I'm going to write options with the bracket open, and we are going to write reaper dot plot dot width is equals to 8. Then again reaper dot plot dot height, which is equals to 8. And now we are going to use ggplot user count comma AES X equals to Y equals to percent underscore total comma fill to user double bracket plus, then we are going to use geom underscore pole color equals to gray 20 on size equals to 0.7 plus polar y comma start equals to 0 plus geom underscore text AES label equals to scales and then double colon and there's no space here, percent and a percent underscore total, and it's going to be double bracket as well, comma. Now we are going to write position equals to position underscore stack b just equals to 0.5 comma size equals to 10 font face equals to bold and for clarity, and color is equals to, I have already selected the color and using the same color theme, so 46465E and bracket close, then I'm going to add plus, and now I'm going to use scale underscore fill underscore manual. Yeah, it is scale underscore fill underscore manual value equals to sheet hashtag 91T8E0 and comma, then again hashtag 42A0AB, and now we are going to write name. Name is types of riders. Take equals to C bracket close. Casual comma members labels casual member comma annual member double bracket close plus, and then labs title equals to distribution of riders comma, and we are going to give it subtitle equals to what percentage of riders are using the cyclistic services, and add caption which is equals to data Data is from Motivate International a Chicago-based fictional Chicago-based company, bicycle service company. And now we're going to write theme or void, and open bracket close plus. Then we are going to write theme plot dot title is equals to element underscore text h just equals to 0.5 comma size equals to 22 comma base equals to bold comma color equals to hashtag 42E0E and comma. Now it's written. Now we are going to write a plot dot subtitle which is equals to element underscore text and it is h just equals to 0.5 comma size equals to 16 comma base equals to obviously bold for clarity and comma color already we have pre-selected. You can use any type of color if you want, right? I am using this as an example case. Okay? Comma. Now we are going to write plot dot caption is equals to element text size equals to 8 color equals to gray 35 close and I give a comma then legend dot title is equals to element underscore text and size of it in comma page equals to bold comma color equals to hashtag 42A0AB comma legend dot text equals to element text. Again we are going to write size equals to 14 comma color equals to gray 20 and now we will close the case and this is the complete code and we are going to now execute and this is the pie chart. 44% casual member, 56% annual member. It is very clear, transparent, and no problems. Now, how does it work? How this code works? First of all, keep this in your mind that I'm going to only explain this code for your understanding purposes. And after this, for other data visualization codes, I don't think so that I need to explain it to you guys. The code because once you get the gist of this code you can understand the other code very easily. Secondly, you can Google it to understand it and their code is lengthy but not very difficult to understand. What happened here is that I use option reaper plot width 8 and reaper plot height 8. I am giving the height and width to this chart which is in by default inches. Number one. Number two, I use it is not a part of ggplot, so it is a separate code. Then we fetch the ggplot library And the data we use for this pie chart is from user count. And then we define the axis. X I have deliberately given nil because we are creating a pie chart, and in pie chart we don't need to give x-axis value. We only need to give y-axis value, as you can see. So what do we give the y-axis? We have given y-axis the total percentage, and then we use fill equals to user, which means we need to add this both areas with color. Okay, and for doing that we use geom goal. What geom goal does is that it gives the border thickness and the color, and it draws the bar chart. Okay, now the question you might ask that it draws the bar chart, then why this pie chart? Why there is a pie chart here? So we use function code polar y start 0. What this does is it converts stacked bars into a pie chart by wrapping them around a circle. So we have to do this. There is not no direct function of creating a pie chart directly, according to my knowledge. We have to use geom pole first, then we have to use the code polar. So that is a limitation, I think, and I haven't figured out any other way to do this. So this is one point. And secondly, what is a geom text? So geom text will place the percentage of label inside the pie slices, as you can see. So that is one part. And also scale percentage, it will for what type of value I want to represent here or showcase here, I want it in percentage, so I have to use this function. Secondly, the positioning, where do I want to place it? So I wanted to place it in center, so I have used this code here. And size 10, front font face bold, color is this. So what this does is it defines the size, and I want the text in bold and the color. I have used the hex code already. So it is an exemplary code for you guys. Secondly, what do I want to give the color? How did I give this light blue and this annual member dark blue? So what I did was I used scale fill manual and values equals to C, and this is the color code for the casual members, and this one is for the annual member. Light blue and dark blue. This one is the light blue one, and this one is the dark blue. You can use any type of color. I'm just giving you context and trying to explain to you guys how this code works. So this is one thing. Secondly, now I need to give the title. Here, as you can see, type of riders, casual member, annual members. So name, breaks, label, these are the titles which you can see here. Type of riders, casual, annual. And for these titles, we have used labs code here. Now the last thing is the theme void. What theme void does is it simplifies the chart and make it little bit clean. That is the only function of this. So the placement and the color positioning and the color use, it is used for formatting purposes only. So you can play around with it, and you can have different results, and it's a very useful code. Without this, we can have a chart, but it would be not very clear. So I hope you guys understand this point. And so guys, now we are going to make the bar chart pertaining to percentage of bike used by casual rider. And I'm going to write the code. Option Reaper dot with equals to 10 comma Reaper dot plot dot height ggplot bike underscore usage axis will be x will be denoted by bike comma y is equals to percent underscore total comma fill is equals to percent underscore total plus geom bar that equals to identity plus. Now, as you can see, we are not going to use this coord polar function because we don't want to wrap it around. We want the bar chart. For pie chart, always remember that we use this function as per best of my knowledge. So now geom underscore text AES label equals to scales colon percent underscore total. We are going to use B just for justifying the positioning. Size equals to 8 comma font page obviously bold and color equals to weight 20 and now we are going to use scale underscore fill underscore gradient pi equals to percent hashtag 42A hashtag 42A0AB comma low equals to 91DE0 now we are going to use the labs function for titling. I'm going to give, you can give whatever, but I'm going to give percentage of bike used by casual writers, comma, subtitle equals to 7 out of 10 writers uh, 7 out of 10 writers use the classic bike ride. And one more thing we're going to add. Obviously, we need to add the caption. What is the caption? Same as above, data from Motivate International and X equals to types of bikes and Y here we don't need to give any value. Okay, so it is going to be blank and plus And now we're going to use theme. Let's go mini, null, bracket open, bracket close, and plus sign, and right theme, bracket, plot, dot title equals to element underscore text size equals to 22 and comma color equals to hashtag 4280AB and face equals to bold. Now comma. Now we are going to copy this one from here, I think, no, here to here, right? Same pattern, different number used. So I'm going to use plot subtitle equals to element underscore text size equals to 16 comma color equals to gray 20 and face equals to bold. Now we are going to use caption element here. Here we are going to use 8 color, and for color we are going to use gray 35, and there is no requirement for this. So this will conclude the caption part. And now we are using axis dot text dot x, which is equals to element underscore text. What is the element of underscore text? The element underscore text is size, which is equals to 14. Color is, now color we are going to use gray 20. And the face bold, comma, and we are going to copy this, paste it. Now for y, we are not going to give any value. So it is going to be element underscore, because we are not going to give any value. This is going to be blank. Okay. And again, we are going to copy this. And now here, we are going to write axis. We're going to copy x again, and this part is going to be text. And what we are going to write here is this new part is this one, but different values. I'm going to give it a size of 15, color, obviously hashtag O2APA, sorry, 0AB, page is bold, blank, legend dot position, which is equals to none. And we are going to close it. Now we are going to run or execute the code. So guys, now we are going to execute the code. So as you can see, percentage of bike used by casual riders, 70% classic, 7 dog, and 24% electric bikes. And now we are going to check the time spent on bikes by riders, both casual and annual member. And the code for that is option reaper dot plot dot width equals to 8 comma ripper dot plot dot height is equals to 6 ggplot writer underscore time underscore user comma axis x equals to user y equals to average underscore time comma fill is equals to, we want to fill average time and double bracket plus, and now we are going to use in the geom underscore call and define the width 0.8 plus geom underscore text AES label equals to F so time, and now we just equals to 2 for positioning and size 8 color equals gray 20 font base was bold plus scale underscore fill underscore gradient high equals to stack 4280 तो color value hashtag 91D8E0. Now we are going to use we want title will be average time spent by riders on bikes, comma subtitle was to what is the subtitle? Subtitle we can say casual riders spend twice as long as average member riders member on average. And now comma caption will be same data colon motivate international defining the X is user, Y obviously we have denoted Y with time of what in minutes. Yeah, push this and now add plus and add theme underscore minimal, both bracket plus theme plot title equal to element underscore text. Size is to color equals to hashtag 4280AB, comma face equals to bold and comma. Now we are going to write on subtitle. Subtitle equals to element underscore text. Size equals to 14, comma color equals to gray, and face equals to bold, comma dot caption equals to element underscore text, and we are going to give this size 8, color which is equals to a 35, comma. Now work on axis dot title dot x equals to element underscore text, size which is equals to 15, color equals to obviously color is going to be hashtag 42A0AB, and now we are going to add face which is bold. Now we have to copy the same code from here and paste it. This is the Y value. And now we're going to copy both of these again. Type it here. And this one we are going to create 20. And now we're going to add one more axis dot title y. So this is element. I think I might have written this. That is 14. element underscore blank, bracket open, bracket close. Legend dot position equals to none, close. So to give it a value x. So this is the code and we are going to run it. So when we execute it, as you can see, average time spent by riders on bikes, casual rider spends twice as long as member on average. Now further, we have already checked the casual rider time spent in minute 28 and annual member 13 minutes approximately on average. Now we are going to check average time spent by riders on different type of bikes, casual and annual both. So for that, we are going to write another code. Option equals to sweeper dot plot dot width, which is equals to 8, and sweeper dot plot dot height, which is equals to 6. So height and width, we are going to keep it same. Now we are going to add that. I'm going to copy this, this, this till scale. And we are going to paste it here. Okay. Now we are going to modify it a little bit. For x-axis, now I don't want the user, I want the bike types. For y, average time and fill underscore average time is okay. Geom call, I will leave it at blank. And for geom text, average underscore time, we just do 8, color is gray 20, and fish font is bold. Scale fill gradient high is same, no changes. And now we are going to add facet wrap. And now we are going to add user and plus. And now labs title equals to average time spent by riders on bikes. On the average casual riders using docked bikes spent we have to remove this bracket and the most time on rides, comma, because we want to add caption also. And for caption, I'm going to copy it from here and then modify it if required. Only one thing is required to be modified, and which I'm going to do in a gist. It was user, now it is type of bike. And for this average time spent. And then theme minimal, I'm going to copy this and modify it here. So it is 22, 14, 8, 15, 15, 14. This one I'm going to replace with 10. How I know that this should be 10? Because after countless trial and error, I figure out that this is the right value, right size to represent this type of data. You need to constantly check and modify and tweak it. So now we are going to execute the code. So as you can see, the time spent by Castle Rider is 26 minutes, 50 minutes on dog bike, 26 on classic, and 20 minutes on electric. And for annual member, 14 minutes on classic and electric bike, 12 minutes. So this is one thing. Now we are going to check average distance travel in kilometer by both members. So the procedure is going to be same. We are going to copy this whole code and modify it. So now we are going to copy the same code and add here. And instead of this, we are going to write it average distance. This will be users. And this will be also user. Average distance. Average distance. And width, which is equal to 0.8. The size is going to change here. 14. This wrapped face wrap user function is not required in this. And slight modification here also. I'm going to change this from average time. This now average distance. Bracket km bracket close. Now we are going to execute the code. So as you can see that average distance traveled by riders on bikes is casual member 2.2 kilometers on average, annual member 2.1 kilometer. Now moving forward, we are going to check average time spent on riders on different type of bikes in kilometer. So for that, I'm going to copy this code and modify it. So copy, modify. Now I want it different. This is distance, bike types, bike, or everything is okay. Now average time spent on riders on bike. Now I'm going to change the on different types of bikes. We are going to change the distance traveled by riders on different bikes. And we are going to modify the time area again in distance. Here also I'm going to modify this one into distance. And as you can see that now we can execute the code. So we are going to execute the code. And as you can see, average time spent on riders, 5 riders on different bikes, classic bike, dog bike, electric bikes, 3 categories. Annual casual member 2.15 kilometers on classic, 2.04 on a dog bike, and 2.44 on electric. On the other hand, annual member has 2.01 kilometers on classic and 2.39 kilometers on electric bikes. Now further we are going to write a code for rides throughout the day. So it will be a comparison of peak hours. We are going to write a code for riders throughout the day. So it's going to check which are the peak timing of the rides. So we are going to write option reaper dot plot dot width 12 comma reaper dot plot dot height equals to 8 and options SCIPEN equals to 999 set WD and we are going to give the link Kaggle dash working ggplot our is work of will share my group equals to geom that now here we are going inverted commas and write identity yes scale menu value is C. So now we need to define the color for it. So to write, I am going to give inverted commas hashtag 91T8E0. Second, I'm going to write the same hashtag 42A0AB. Now we are going to write name equals to type of writers and comma breaks equals to C casual 1 minute casual comma member now I'm going to give labels equals to C. So what will be the label? So label is yes. Member, comma, And so this is the scale fill. So I need to add titles. We're going to use labs title equals to rights, total rights to out. Okay. Subtitle equals hours. We are going to write caption equals to rights to out 30. Peak during early evening, comma, and sorry, I have written it wrong here. I thought I was writing it on title, but it is not title. Title I have already written. Labs title is right throughout the total right throughout the day, and writers speak during the early evening hours. Caption, it is caption, sorry. So I'm going to write the same caption as always. Data, colon, motivate, international, comma, x equals to hours, comma, y equals to number of writes and now we are going to add theme minimal. For clear visualization purposes, plus theme dot subtitle equals to sorry title subtitle. Actually, I'm going to copy this and then I'm going to write title element underscore text size equals to 22, color equals to hashtag 4280AP. Hashtag. And now I'm going to write space equals to bold, comma, but now I'm going to write copy this whole code, but subtitle will be 14. This is the 20. and here it's 14 and it is subtitle. And now I'm going to copy this code. This complete code is going to be copied, pasted again for caption. Caption element text size will be 8 and it will be grade 35. For caption we don't need space bold, so we are going to close it here. And now legend dot title was to element underscore text. Size was to color was to hashtag 4280AB to be comma legend dot text equals to element underscore text size equals to 14 comma color p comma. Now access dot title dot x equal to element underscore text size equals to 15 color equals to hashtag 4280AB comma secondly face will be bold comma. And now we are going to copy this in here, copy paste, and this is going to be y. Value will remain same for both. Then we are going to use x again. This time it is 10 with grade 20 and again copy this. Now it would be 10 also, but not on x but y. And here it is. This is the complete code, and now we are going to execute it. So this is the chart, hourly chart, and it is used for showing the peak hour usage and on which hour the bike usage was less for both member, casual and annual. So it is a very clear chart. In my presentation slide, for much easier understanding, I have used line chart. So it is very easy now to understand what happened. Now we are going to calculate days of week riders took rides, which days of the week were most demanded for both members. So for that we are going to write another code. And guys, now we are going to do nothing. We are going to copy this code and then copy paste. After pasting this code, I'm going to make a slight changes. For example, here, instead of hours, now because we want to calculate by days of week, on which weeks there was more rides. So for that, the days of week, and here I'm going to denote it as days underscore, sorry, not days, day. Let's, the reason for day is that I want to keep it simple. So day of week, because we are individually targeting each day and checking on which day there were more rides compared to rest of the days for both members. So that's why day of weeks. And number of ride is okay. Well, group user is okay. Identity, now we have to make a little bit modification here. Day of week. Here it's not required. It's number of rides which I want to calculate anyhow. And now we are going to fetch. And as you can see, rides throughout the day, Monday to Sunday, casual versus annual member. And on the x-axis and y-axis, number of rides and total number of rides are here. So this is the whole crux. And now we are going to move towards rides throughout the months of year. So it is also very easy. So guys, now we are going to copy this code again and add it here and modify it from days of week to months. Here I'm going to write as month. Month. Rides throughout the days, not that is rides. We are going to write monthly rides. Subtitle, we are going to write different, and I'm going to write it as summer, the summer months have the of rights are okay, and all of the details looks okay. Now we are going to execute the code. So guys, this is the result. Monthly rights, the summer months have the most number of rights. Casual versus annual member, January to December. Total number of rights on y-axis and months on x-axis. So this is the whole outcome of this project and the exercise. Now I want to move towards my presentation part, and I want to give a brief summary to let you guys know what is the crux of this whole project and how you can explain the same results to the stakeholders or the business owners or the clients or the investors. So we are going to move towards my presentation part. So thank you for staying with me for so long. It's a long project, but I hope you guys are going to like it, and Now we can move towards the presentation. So guys, this is my Google Capstone project for Cyclistic dataset. But before we deep dive into the data visualization and my recommended strategies, let me first highlight a few key factors. This way you will have the perfect context to really understand the story behind the numbers. In this cyclistic dataset, riders are grouped into two main categories. Number one is casual rider, and number two are annual member riders. The difference between both of these categories in the user base is casual riders are those riders who don't have subscription, they pay per ride or use short-term passes. They are often noted to be tourists or weekend users or people using these services occasionally. Their rides are usually longer in duration, more leisure focused. However, when we compare them with annual members, it is noted that they have annual membership, they have subscription-based plans, they pay a flat yearly fees for unlimited or discounted rides. They are often noted to be commuters or residents using bikes for daily transport. Their rides are usually shorter in duration, more commute focused. One more thing I would like to add that Chicago Cyclistic Bike Company offers three types of bike services. Number one, classic bikes. Number two, top bikes. And number three, electric bikes. Further, if we want to check the user-based distribution of cyclistic riders, annual member makes up 56% of the ridership, highlighting a stronger preference for long-term commitment. And when we compare them with casual member makes up to 44% of the ridership, representing flexible and short-term usage. Further, if we want to know what is the percentage of bike used by casual riders, it is noted that casual riders tend to use classic bikes 70% of the time, top bikes 6% of the time, and electric bikes 24% of the time. And when we compare the same number with annual members, it is noted that they use classic bikes 77% of the time, dog bikes 0%, that means they don't prefer dog bikes, and electric bikes 23% of the time. Further, if we want to check average time spent by riders on bikes in minutes, it is noted that casual bike riders tend to spend 28 minutes per ride and member bike riders 13 minutes per ride approximately. Further, if we want to check average time spent on different bikes by casual riders in minute, they tend to spend 26 minutes on classic bike, 50 minutes on dog bikes, and 20 minutes on electric bikes. And we compare the same number with the annual members, it is noted that they tend to spend 14 minutes on classic bikes and 12 minutes on electric bikes. Now, if we want to check what is the average distance traveled by riders on bikes in kilometers, it was noted that casual bike riders spent around 2.2 kilometers per ride and member bike riders spent 2.1 kilometers per ride. And if we further bifurcate by bike type and the distance traveled in kilometers, it was noted that casual bike riders spent 2.15 kilometers on classic bikes, 2.04 kilometers on dog bikes, and 2.44 kilometers on electric bikes. And the member riders spent nearly 2.01 kilometers on classic bike and 2.39 kilometers on electric bikes. So guys, as you can see, this is a line chart which tracks the ride activity throughout the day, with peak hours shown along the x-axis and the number of rides taken on y-axis. We can clearly see the annual member consistently ride more than the casual users, especially during the morning commute between 6 to 11 a.m. Their usage rises sharply in this window, reflecting daily work or school travel or commute. Casual rider, on the other hand, starts slower in the morning but steadily increase throughout the afternoon. By the late afternoon and early evening, between 4 to 6 p.m., casual usage spiked significantly, sometimes even surpassing the annual mean. To provide even more clarity, I have further broken down this line chart into two 12-hour cycles. The first cycle, as you can see, it represents the early morning and afternoon chart, represented by bar chart. Early morning AM hour detail for casual riders, and in comparison to early morning AM hour detail for annual riders. And in the next cycle, which is the evening and night cycle, as you can see, I have made a bar chart for casual riders as well as member riders. Furthermore, the key insight which I have extracted from this process is that primarily annual members commuting peaks around 8 to 11 am in early morning. Both casual and annual member are active with highest total rides at 5 p.m. Casual riders are more dominant in the afternoon and early evening. Annual members dominate the early morning scene. Operational takeaways: allocate more bikes and maintenance in the afternoon, evening to meet peak demand. Now I have done the same process for annual member rides by days of the week, as you can see, from Monday to Sunday, and for casual member as well, from Monday to Sunday. And the key insights with suggestions are: number one insight was ridership peak on weekends, so that it means for casual riders, so we can offer special weekend passes or promotion to attract more casual riders. Number two, annual member are commuters, so ensure high bike availability near business district and transit hubs on weekdays. Third insight was casual member are weekend riders. Launch a targeted marketing campaign on weekend to convert casual rider to annual members with a simple upgrade offer. I have also bifurcated the whole data on casual versus annual riders by month. As you can see, this is annual member rides by month from January to December. And in comparison to casual member ride by month from January to December. The key insight is that annual members are the backbone of the service. They ride consistently throughout the year, primarily on weekdays, suggesting a reliance on service for commuting and regular transportation. Casual members, on the other hand, are the key to growth. They are seasonal and weekend riders who drive the massive spikes in ridership during the summer or weekends. My suggestions are: capitalize on the summer rush. For example, launch a targeted marketing campaign in the late spring, like April or May, to capture the casual rider as the weather warms up. Offer promotional membership or incentive to encourage signups. Secondly, convert casual riders. Develop a simple in-app upgrade path for casual users who have completed a certain number of rides. For example, your next 5 rides could be free with an annual membership. Type of message could be effective. Finally, optimize the bike fleet management. Relocate a larger portion of the bike's fleet to recreational areas, park, and tourist hotspots on weekend and during the summer to meet the casual riders' demand. Ensure efficient supply is available in the business district on weekdays for annual members. Now, finally, my actionable insight and recommendation after checking and analyzing the whole data set. Number one, launch a targeted advertising campaign for casual rider. Plan marketing effort leading into summer month as casual rider peak during this season. Number two, use social media in-app promotion and geo-targeted ads to attract more riders. And secondly, encourage membership conversion with cost saving. For example, highlight the cost saving of a membership versus casual rides through personalized marketing. Offer promotions such as free trials, summer discounts, or referral bonuses to incentivize signups. Number three, introduce a loyalty and reward program for members. Implement a point based system where members earn reward for frequent rides. Provide incentive like rides credit, exclusive perks, or discount on partner services to enhance retention. Number four, expand dock bike access to members, annual members. That is, currently dock bikes are only available to casual riders. Allowing member access to these bikes can improve user experience and increase membership appeal. You can also a, add 1 day free access or one free ride access to the annual membership. These strategies align with the observed ride behavior and have the potential to increase the membership conversion, boost engagement, and optimize revenue growth. So, guys, thank you so much for watching. I am Adnan Shafiq, and this was my Google Data Analytics Capstone project on Cyclistic dataset. Through this project, I have shown how raw data can be turned into meaningful insight and actionable strategies. Because in the end, data isn't just a number, it's the key to better decisions, smarter strategies, and lasting impact. This is just the beginning. Welcome to the journey of data domination. Connect with me on LinkedIn, on my LinkedIn ID, explore more of my work on Kaggle, and don't forget to subscribe to my YouTube channel, Data Domination. Thank you.